It's Jeremiah the Geometry Cowboy talking to you about the distance formula. What did the cowboy say to the pencil? Draw, partner!
First vocabulary term is distance. That's the length of the segment measured from one endpoint to another endpoint. So here we have two endpoints, point A and point B. And the length of the segment would be 28 feet. That's our distance between points A and B. A perfect square is the square of an integer. So here you can see we have 20 different perfect squares. A square of an integer, so our integers, remember, are -1, 1, -2, +2, -3, +3. So if you square those, you end up getting a perfect square. So that would be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. Those are your perfect squares. Those will be important today because we will need to know the perfect squares in order to simplify radicals, which is what we're going to be doing later on. Now, the distance on a number line. The distance between 2 points on a number line is the absolute value of the difference between their coordinates. So here, you can see we have two coordinates. We have x1, which is at -5, and x2, which is at 3. So if I wanted to figure out the distance between 2 points on this number line, what I would do is I would take the difference of those two coordinates. So I would take 3 and subtract -5. Or I could do -5 and subtract 3. Either way. After I take that difference, I'm going to take the absolute value of what I get. So my difference, I make sure that I turn positive. So if I take x2, which is 3, and subtract x1, which is -5, 3 minus -5 turns into 3 plus 5, which is 8. And the absolute value of 8 is still 8. So your distance between x1 and x2 would be 8 units. If you were to do it the other way around, the absolute value of -5 minus 3. What's -5 minus 3? That's -8. And then the absolute value of that is still +8. So it doesn't matter which order you go in. Also note that we are using absolute value because distance is always positive. Think about if you're driving somewhere. You drive 5 miles. You're never going to drive -5 miles. You're never going to run -3 miles. All your distances need to be positive, which is why we are using absolute value. And last thing, we could also just count on a number line. If you had numbers that are close together and you want to find the distance and you forget that it's the absolute value of the difference of their coordinates, you just go 1, 2, 3, 4, 5, 6, 7, 8 units. And that is the distance between these 2 points.
Examples.
Now, example 1 says find the measure of segment DE. Remember, when there's no segment bar above DE, that means find the measure of DE. So the measure of DE is just the distance between points D and E. And we know the distance between 2 points on a number line, right? That's just the absolute value of x2 minus x1. So all we have to do now is pick which of these points is going to be our x2 and which is going to be x1. It doesn't matter. You'll get the same answer either way. So I'm going to say that E at -8 is going to be our x1, and D at 7 is going to be our x2. So we're going to take 7, plug it in for x2, take -8, plug it in for x1. We then simplify. What's 7 minus -8? That's the same thing as 7 plus 8. And the absolute value of 7 plus 8 is 15. The absolute value of 15, absolute value of a positive number, just stays positive. So your answer is going to be 15 units. Remember, distance requires units. So if it doesn't give you inches or feet or centimeters, you just write units at the end. Last but not least, if the numbers are close together like they are here, you can always just check on your number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units between points E and D. Perfect. Got the right answer.
Saddle up, partner. Time for a new try.
Okay, doing the same thing here. So we want to find the measure of segment CA. Remember, there's no segment bar above here, so it's the measure of CA. So that would be the distance between points C and A. So how do we find the distance between 2 points on a number line? We know that. It's the absolute value of x2 minus x1. Now, which one do we want to make our x2 and which one do we want to make our x1? It doesn't matter. You'll get the same answer either way. So we're going to make our C at -1, x1, and our A at -10, x2. So we go ahead and plug in -10 for our x sub 2 and -1 for our x sub 1. So we have the absolute value of -10 minus -1. What's -10 minus -1? The same thing as -10 plus +1. So the absolute value of -10 plus 1, -10 plus 1 is going to be -9. And the absolute value of -9 turns that positive. So we end up getting +9 units between points C and A. And if you want, again, since they're close together, you can just count to make sure you did it right. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Cool. Now let's talk about the distance formula. So let's assume that our 2 points are not on a number line. Here they're on a coordinate plane. So if I want to find the distance between points A and B, the distance between points A and B I can find by taking the square root of x sub 2 minus x sub 1, the quantity squared, plus y sub 2 minus y sub 1, the quantity squared. And again, we just get those values from our given points, their location on the coordinate plane. And we'll get into how this works right now. Now, example 2 says find the distance between each pair of points. And again, we have points A and B. So if we want to find the distance, D, between those 2 points, all we have to do is use the distance formula. Now, the distance formula requires a x sub 1 and a y sub 1 and an x sub 2 and a y sub 2. So which one are we going to make which? It actually doesn't matter. You'll get the same answer either way, as long as you make this one x sub 1, y sub 1, and this one x sub 2, y sub 2, or this one x sub 1, y sub 1, and this one x sub 2, y sub 2. You just can't make this x sub 1, y sub 2. That'll make you get the wrong answer. But if you choose either one to be x sub 1, y sub 1, and the other one to be x sub 2, y sub 2, you're good to go. So here I have already color coordinated it for you. So let's just make this one x sub 1, y sub 1, and this one x sub 2, y sub 2. Now, all we have to do is plug in the corresponding coordinates. So, I'm going to plug in 4 for my x sub 2. I'm going to plug in 0 for my x sub 1. I'm going to plug in 3 for my y sub 2. And I'm going to plug in 0 for my y sub 1. Now, all I have to do is simplify this according to the order of operations, PEMDAS. So, I start with my parentheses. 4 minus 0 is 4. 3 minus 0 is 3. I then do my exponents. 4 squared gives me 16. 3 squared gives me 9. I then multiply or divide. Nope. Add or subtract. Yeah, I can add these two. What's 16 plus 9? That's 25. And then the square root of 25 is going to give me 5 units. So the measure of segment AB, the distance between points A and B, is 5 units. Don't forget your units. Remember, this is distance. It requires units if it doesn't give you any.
Don't just sit in a barrel like a rodeo clown. You try.
Okay, doing the same thing here. I want to find the distance between points P and Q. And in order to do that, I need to use the distance formula. So, which one am I going to pick to be x sub 1, y sub 1? And which one am I going to pick to be x sub 2, y sub 2? It doesn't matter. But I have already color coordinated it for you, so why not pick P to be our x sub 1, y sub 1, and Q to be our x sub 2, y sub 2. So now all we have to do is plug those corresponding coordinates into their spots. -4 is going to go in for my x sub 2. -3 goes in for my x sub 1. 1 is going to go in for my y sub 2, and -2 is going to go in for my y sub 1. Now we simplify according to the order of operations. We do the parentheses first. So -4 minus -3 is the same thing as -4 plus 3. Same thing over here. 1 minus -2 is the same thing as 1 plus +2. So what's -4 plus 3? That's going to be -1. And what's 1 plus 2? That's 3. So what's -1 squared? -1 times -1 is +1. And then 3 squared is 9. I then add these together. What's 1 plus 9? That's 10. So I get the square root of 10. Can I simplify this? No, there's no perfect square that goes into this, and we'll get into that more later on. This is as simplified as this radical gets. So you just leave your answer as rad 10 units. That is the distance between points P and Q. Now let's talk about simplifying radicals with numbers. Today we're just going to be dealing with square roots. So to simplify square roots, break into 2 radicals that multiply together to make the original radical, where the first radical is a perfect square. 4, 9, 16, 25, 36. Okay, notice how I left off 1 because 1 is going to go into anything, but that doesn't help you break it down any further. So the square root of 180. We know 180 is not a perfect square, so we can't just take the square root of it. So what we're going to do is we're going to break it into 2 separate radicals that multiply together to make 180. And that first radical has to be a perfect square. So 4, 9, 16, 25, 36, one of those. Here, I need to figure out what perfect square goes into 180. So I divide each of these into 180 and see if they go in perfectly. And actually 36 divides in evenly to 180. So I know the square root of 36 times the square root of 5. How did I get 5? Well, 36 goes into 180 5 times. So the square root of 36 times the square root of 5 gives you the square root of 180. Now, why did I pick 36? Because it's a perfect square. And what's the square root of 36? That is 6. The square root of 5, we can't break that down any further, and you can't take the square root of it, so it just stays under the radical. So you're left with your answer, which is 6 rad 5. Now, I know what most of you probably did. You were like, oh, 180. I know 9 goes into that, right? Well, you could have done that also. So if I broke this down into two radicals that multiply together to make rad 180, and the first one has to be a perfect square. So 9, because we know 9 goes into 18, right? So the square root of 9 times the square root of 20. Now I can simplify this, so the square root of 9, the reason we picked 9, it's a perfect square, so when I square root it, it's 3. The square root of 20, can I break that down further? Is there a perfect square that goes into that? Yeah, 4 does. So this, the square root of 20, can be broken down into rad 4 times rad 5. Now, the 3 stays out front. The square root of 4, we now turn that into a 2. And then the square root of 5, you can't break that down any further, and you can't take the square root of 5, so it just stays rad 5. So your final answer should be 3 times 2 times rad 5, which is 6 rad 5, which is the exact same thing we got over here. So there are multiple different ways to get your answer. The only issue is sometimes if you pick too small of a number, you have to keep breaking down that second number too many times. So try to get your biggest perfect square that goes into your radical evenly. So example 3 says find the distance between each pair of points. So again, to find the distance between points x and y, I need to use the distance formula. So in order to use the distance formula, I need to pick one point to be x sub 1, y sub 1, and one point to be x sub 2, y sub 2. Again, it doesn't matter. You could have flipped these. Now, I plug those points into their corresponding spots. So 2 goes in for x sub 2, negative 8 goes in for x sub 1, 2 goes in for y sub 2, and then 6 goes in for y sub 1. I then simplify this according to order of operations. So I start with my parentheses. So 2 minus negative 8 is the same thing as 2 plus positive 8. And 2 minus 6 is going to be negative 4. So what's 2 plus 8? That's going to be 10. And then 10 squared becomes 100. What's negative 4 squared? That's 16. So I get 100 plus 16, which is 116. Oh, well, that's not something I can take the square root of, but it is something I can simplify. So if I were to write this in simplest radical form, what I can do is break it up into two radicals that multiply together to make rad 116, one of which has to be a perfect square. So what perfect square goes into 116? 4 does. So I'm going to make it rad 4 times rad 29. Those two numbers multiply together to make 116. That's why I can simplify it like this. Now, I picked 4 because it's a perfect square. What's the square root of 4? That's 2. Rad 29 is actually a prime number, so there's no other number besides 1 or 29 that goes into 29. So I'm going to keep this rad 29. So my final answer, the distance between points x and y, would be 2 rad 29 units. Remember to put units.
Quit horsing around. Time for a U-try.
Okay, doing the same thing here. I want to find the distance between points J and K. And in order to find the distance between those 2 points, I need to use the distance formula, which means I need to pick one of these points to be x sub 1, y sub 1, and the other point to be x sub 2, y sub 2. So when I do this, I can now plug them into their corresponding spots. So what is x sub 2? That's 4, so that goes in there. X sub 1 is negative 5, that goes in here. Negative 7 is our y sub 2, that goes in here, and negative 10 goes in for our y sub 1 here. I then simplify this according to order of operations. So we go ahead and start with the parentheses. 4 minus negative 5 is the same thing as 4 plus positive 5, and then negative 7 minus negative 10 is the same thing as negative 7 plus positive 10. So then we simplify further. 4 plus 5 gives you 9, and then negative 7 plus 10 gives you 3. So 9 squared then is 81, and 3 squared is 9. Add those together, you get 90. Now, is 90 a perfect square? Can I take the square root of this? No. But I can simplify this. I can put it in simplest radical form. So what perfect square goes into 90? Oh, I know that. That's 9, right? So this is going to break up into rad 9 times rad 10. Now, we picked 9 because it's a perfect square. The square root of 9 is 3. And then rad 10 could break up into rad 5 and rad 2, but neither of those are perfect squares. So we just leave rad 10 as rad 10, just like we did in the previous previous U try. So what is 3 times rad 10? That's 3 rad 10. So the distance between points J and K is going to be 3 rad 10 units. Remember to put units when they don't give you feet or inches or centimeters. Now example 4 says find the value of C such that each pair of points is 5 units apart. So we have 2 points here, but we are missing the y coordinate for our second point. Well, we have to figure out what y coordinate can I put here that would make these points 5 units apart. So 5 units apart, that obviously means distance formula. And if we are using the distance formula, we need an x sub 1 and a y sub 1 and an x sub 2 and a y sub 2. Now all we have to do is write our distance formula and plug in what we know. We know our x sub 2 is 3, so that goes in here. We know our x sub 1 is 7, that goes in here. We know our y sub 2 is c, so that's going to go in here, and y sub 1 is 2, that's going to go in here. We also know our distance, right? We know the distance between these 2 points has to be 5 units, so we put a 5 where our d is. Oh, interesting. Okay, so now we have everything except this c, so we're going to have to solve for our c here. So to solve, we simplify first. Again, we start with our parentheses in here. 3 minus 7 is going to give you negative 4. Over here, c minus 2. I can't subtract these 2 things. So what I do instead is I take this quantity and I square it. Well, what's c minus 2, the quantity squared? That's the same thing as the quantity, c minus 2, times the quantity c minus 2. So I actually have to FOIL c minus 2 times c minus 2. And when I do, I end up getting c squared minus 4c plus 4. Now I simplify further. What is negative 4 squared? That's 16. And then I can add that 16 with the 4 over here, and I get 20. So under my radical now, I have the square root of c squared minus 4c plus 20. So how do I simplify this? Well, again, I'm solving for c. So I need to get rid of this radical. How do I get rid of a radical? Well, I square both sides, right? If I square both sides of the equation, the square and the square root are going to cancel each other out. So the square and the square root cancel each other out. Over here, 5 squared is going to give you 25. And this should look somewhat familiar to you. I have to get this equation over here, this quadratic trinomial, set equal to 0. And in order to do that, I subtract 25 on both sides. I subtract 25 on both sides, and I get 0 is equal to c squared minus 4c minus 5. Why did I do that? Because I can now factor this and set each term equal to 0 and solve for c. So how do I factor this? Well, you may have learned a bunch of different ways, but in my class, we teach the magic X, where our a value, which is 1, times our c value, which is negative 5, goes on top, and our b value, negative 4, goes on the bottom. So what 2 numbers multiply together to make negative 5 and add together to make negative 4? That would be negative 5 and positive 1. I then divide both of those by my a value, which is 1. That's the number in front of c squared. And I write my factored form going bottoms up. So it's going to be 1c minus 5 in the first parentheses and 1c plus 1 in the second parentheses. Now I use the zero product property where I set each of these equal to 0, because this times this equals 0 means that either this is equal to 0 or this is equal to 0. I solve for c by adding 5 to both sides. I get c is equal to 5. On this side, I subtract 1 from both sides. I get c is equal to negative 1. So my 2 answers here, the 2 c values that would make these points 5 units apart, are 5 and negative 1. Either of those would make these 2 points 5 units apart.
You got a lasso on that concept? You try.
Okay, doing the same thing here. So first, we need to make one of these points x sub 1, y sub 1, and the other one x sub 2, y sub 2. We then write our distance formula and plug in what we know. We know x sub 2 is c, so that goes in here. We know x sub 1 is negative 7, that goes in here. We know y sub 2 is 11, that goes in here, and y sub 1 is 7, that goes in here. We also know the distance between the points has to be 5, so that's what we plug in for d. We then simplify. Inside the parentheses, c minus negative 7 is the same thing as c plus 7. And over here, 11 minus 7 is going to give you 4. Now, c plus 7, we can't simplify that any further. So what we do is we square it like we're supposed to. We do our exponents. So here, c plus 7 squared is the same thing as c plus 7, the quantity, times the quantity c plus 7. So if I FOIL that out, I end up getting c squared plus 14c plus 49. Over here, 4 squared we know is 16. Now I can combine the 49 and the 16, and I end up getting 65. Again, I have a square root, and my c's are under it. This is as simplified as that gets, so I need to get rid of my square root. To do that, I just do the opposite. I square both sides of the equation. So here's squaring a square root. Those cancel each other out. And over here, 5 squared is 25. I then take that 25, subtract it to the other side because I need these to cancel out and this to become 0. If I set this quadratic trinomial equal to 0, I can then factor it using my magic X. Again, my A value is 1, my B value is 14, my C value is 40. So I take A times C, 1 times 40, put that on the top of my magic X, put my B value of 14 on the bottom. I then think about two numbers that multiply together to make 40 and add together to make 14. That would be positive 10 and positive 4. I then put the A value under each of those, and I write my factored form going bottoms up. So in the first set of parentheses, it's going to be 1C plus 10. In the other set of parentheses, it's going to be 1C plus 4, or C plus 4. Now I use the zero product property. Since these two things multiply together to equal 0, I can set either of them equal to 0 and solve for C. So here I subtract 10 on both sides, I get C is equal to negative 10. And on this side, I subtract 4 on both sides, I get C is equal to negative 4. So my two answers are negative 10 or negative 4. Either of those C values would cause these 2 points to be 5 units apart. Now, word problem says a semi-truck traveled 23 miles north on the 405 before turning east on the 91. After traveling 85 miles on the 91, about how far is it from its starting point? Round your answer to the nearest mile. So step 1 in a word problem, we're not scared. We can do this. Step 2, we need to define our variables. So what is this question asking us? It's asking us to find about how far is it from its starting point. So we can say that D will be the distance between the semi-truck and its starting point. So we look at our graph. Where is it starting? Well, the easiest place to have a truck start or anything start would be at the origin, right? 0, 0. We know from this point, the truck travels 23 miles north. So we go up 23 units on the y-axis. It then turns east and travels 85 miles. So it goes 85 miles east. We then figure out, where is it now? What point is this? Well, this point would be over 85, right? So it'd be 85, comma, and then up 23. So 85, comma, 23. That's this point. And I want to find the distance between the starting point and where it is now. So the distance between these 2 points will require the distance formula. There we go. Now I see what we're going to do. We're going to write our equation, which we know now is the distance formula. We then pick one of these points to be x sub 1, y sub 1, and the other one to be x sub 2, y sub 2. Doesn't matter which is which. We plug them into their corresponding spots. We then simplify in the parentheses. According to the order of operations, that goes first. So 23 minus 0 is 23. 85 minus 0 is 85. We then do the exponents. 23 squared, we know, is 529. And then 85 squared is 7,225. We add those together. We get 7,754, which we can take the square root of. No, we can't. That's not a perfect square. But since in our answer, it says round your answer to the nearest mile, we do not have to put it in simplest radical form, which is kind of nice. If it says round to the nearest mile, we could just plug this in our calculator and then round to the nearest whole number. So let's do that. If we plug this in our calculator, we get approximately 88.056799851 miles, which, if we round to the nearest mile, is the nearest whole number. Since it's 0.0, this just rounds to 88 miles. So the semi-truck is approximately 88 miles from its starting point. Remember, since it's a word problem, you need to answer in a sentence. And you're done.